Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on the coefficient of determination and F-tests. So let's have a look at the exercise. The manager of a mall suspects a linear relation between the temperature and the average spendings in the food court of the mall. For this, data is collected for 5 days. Part A of our exercise. Assume that regression analysis results in a coefficient of determination of r squared equal to 0.76. For margin of error of 5%, use a suitable test to test whether the overall model has significant explanatory power. Okay, that's part A. Part B, in how far would the results from part A change if the acceptable margin of error is changed to 1%? In part C, in how far would the results of part A change if the acceptable margin of error remains 5%, but the result is based on data from 102 days. Let's first have a look at part A. Here we want to perform an F-test, and for this we need the test statistic, the F-statistic. This one is given here as r squared divided by k being the number of independent variables, so this is 1 here. Then all of this is divided by 1 minus r squared divided by n minus k minus 1. N is here the number of observations, so it's 5. So we have 5 minus 1, which gives us 3. So the overall test statistic results in 9.5. Then we also need a critical value or reference statistic, and this is given here as f k n minus k minus 1 and 1 minus alpha. We said already k is 1, n is 5, and from the text we have here an alpha error of 5%. So we have to look up in our table of the F distributions the value for F13 0.95. There we find a value of 10.128. This value we compare to the test statistic. There we see that the test statistic is smaller than the reference value. This means our H0 hypothesis cannot be rejected. H0 in this context is that the model has no significant explanatory power. Okay, so if our model has no explanatory power, we cannot reject this. We need to assume it possesses in general no explanatory power. So what happens now if we switch to a different margin of error? So here we have the same test statistic because the margin of error does not impact the test statistic, but we get a new reference statistic. The 2 degrees of freedom, k and n minus k minus 1, remain the same, but alpha changes to 1%. So we have F13 0.99. And in this table, we find a reference statistic of 34.116. So well, if we compare these two values, we see before it has been the case that we cannot reject H0 because the test statistic is smaller. Now it's even more smaller than before, so we can still not reject the H0 hypothesis. This will always be the case. When we reduce the margin of error, the chance of the test actually working and us being able to reject H0 always decreases. So here we can say in this case the model also has no explanatory power. This is here the conclusion from B. Let's continue with part C. Here basically the situation is the same as with A. The only difference being, and that can be seen here from these values, is that the number of observations, the n, changes. Before it has been 5, now becomes 102. So the only difference being the lowest denominator, the n minus k minus 1, becomes 100. This changes then our test statistic to 316.666 and so on. But not only the test statistic is changed, but also our reference statistic, because our second degree of freedom is again the n minus k minus 1. So again, here we change it from 3 to 100. So we get as a reference statistic 6.8953. So, well, reference statistic increases, but test statistic increases as well. But here we can see, well, test statistic is way larger than the reference statistic. So, meaning we can reject H0. And that's basically what we can take away from this part of the exercise. Whenever we increase the number of observations, the chance of rejecting H0 increases as well. Well, reference statistic increases also, but not as strongly as the test statistic. So as soon as I get more observations, my chance of actually rejecting H0, showing that the model has explanatory power, increases. That's also a big problem with regression analysis, because this means if I just have enough observations, add enough observations to my data set, I will at some point always be possible to show even the smallest effects to be significant. Well, we can keep this as one of the insights from this exercise. And in general, I can say, I hope you enjoyed this. I hope, aside from my last comment, you also took something away from this exercise. And if you want to see more of these type of exercises, feel free to visit the rest of the exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.